Hey guys, so I wanted to take a moment to go over the top 5, anyway, questions that were wrong on that current MathSpace on the fundamental theorem of algebra. I did see a lot of errors, not our typical grades, but that's okay. I believe most mistakes might have been just for how they were asking you the questions, because they asked a little bit differently than what I tend to give to you. Okay, so we're going to go through these. Your questions might have been a little bit different numbers anyway, based off of what we see here. Okay, so in this problem, we have a graph when they want us to come up with the equation of the graph. Well, the easiest way to come up with the equation is to find our zeros. So these points right here. And those are pretty simple to find. They're at -3, -2, and a +1. Those are going to be our numbers that we're going to use. So our equation would be y equals, I don't think they wanted f of x when I tried before. So we're going to do y equals, and we're just going to write those as factors. So x plus 3, right, because that's where our -3 is going to come from. -2 comes from x plus 2. And a +1 comes from an x minus 1. And that is all that they wanted. You didn't even have to multiply that out in order to get the full original equation. You could have just left it in that form. Let's see our next one. And I know I'm in period 4, so period 6, you guys had the same questions that were off. Okay. Our next one, so it says find the cubic. So right away, I know I have to have a 3rd degree polynomial with real coefficients, leading coefficient of 1, and those are our zeros. Give your answer in standard form. So this is what we were working with previously. I know -4 comes from an x plus 4. And then I have a 3 plus 1, which means I also have a 3 plus I. I also have a 3 minus I. So when we do our problem, we're going to have an x minus 3, because you go based off of the integer's value, plus I, and then x minus 3 minus I. When we do this multiplication out, we're going to group our x and our integer value. So x minus 3, that's going to be squared. And then we're going to group our i's, and that's going to be an I squared. And because of where this is, I can't get back to my color, but that's okay. So we'll use black for now. And we bring those down. So multiply this side out. X minus 3 squared should not be hard. And then an I squared, remember, is a -1. So we have minus a -1, that becomes a plus. Bring down your +4. And then it's just a matter of multiplying out this cleaned up polynomial here. Again, we'll distribute. We get x cubed minus 6x squared plus 10x. Then you do the 4x squared minus 24x plus 40. And then combine your like terms. So x cubed minus 2x squared minus 14x plus 40. And that's going to be the function that we place in here. And hopefully we did it right. There we go. Good. Okay, so our next question, which of the following could be graphed? So let's see what we got here. Again, looking at our graph that we're given, I want to focus on the zeros. So I want to focus on this point here, which is at a -1, and this one here, which is at a +4. Now the -1 repeats. Remember, if it bounces off, that means there's a multiplicity happening here. So it repeats times 2. When it goes up and bounces off again, it hits it once, and then a second time as it goes around to the next one. So I'm looking for something that is going to be x plus 1 twice, and then an x minus 4. So we should know that an x plus 1 twice is a square. I also know that it's going in an upwards motion, so it should be positive. So it should be A. I think maybe that multiplicity might have confused some of you there. Okay, let's try the next one. Okay, so for this one, again, same thing. I want to look at the graph. I want to find all of these zeros. So I have a -5. I have a -4. I have a -3, a +1, and a +2. I got a bunch of zeros there. So I think it might have been the questioning here that threw off some of us. So they want all the linear factors. Well, your linear factors are your factors. So it's your x plus or x minus something, and they want them all separated by commas. So basically, you do your factors that we know how to do. Oops, x plus 5. And then instead of just writing them all next to each other, we're just simply going to put a comma in between them, because that is what MathSpace wanted. Again, not a hard problem. Oops, I think just the wording of it might have been our issue. Okay, the next part says, write an expression for a monic polynomial that has exactly the same roots as above. So basically just write all of those now next to each other, no commas. Okay. And now part C is which of the following are polynomials whose roots include all of those that we had previously. So we have to have all of the roots that were, let's write them back down again. So we need a root of a -5, a -4, -3, a +1, and a 2. So when I look at each of these, this one has a -5, a +2, a -4, a 1, and a -3. So that's definitely going to be one of them, has all of those numbers. This one's a -5, -4, a -3 twice, because there was a square there, and a +2. So we're missing the +1. So that does not contain all of them. This bottom one was a -5. Oops, sorry, a +5, a +4, a +3, a -1, and a -2. So opposite of what we needed. And the last one is a -5, -4, -3, 1, 2, 8, and 9. But it does have all of those, which were my original. So it does contain all of the intercepts that I originally had. So I'm going to select these two, and we're good. Okay, and it says apart from f of x, how many others are the exact same? Well, there are no others that are the exact same. That is its own function. Nothing's going to be identical to it. And our last one, which I believe was another multiplying out. Yep. So it says find the polynomial with the real coefficients with our given zeros. So we have a 0 of -3 with a multiplicity of 2 and a 0, -5. Okay, so that means when I write this out, -3 appears twice. That's what multiplicity means. And then I have -5i, which means I also have a +5i. So when I write out this function, I'm going to have that x plus 3 twice. And then I'm going to have a +5i and a -5i for me to multiply out. So however you multiply your polynomials, that is up to you. Okay, now, where did I get 25 from? 5i times a 5i is a 5i squared, which means I have 5 squared and I squared. 5 squared is 25. I squared is a -1. So this is a -25. And I was subtracting it because positive times a negative means this is a negative. So a negative of a -25 gets me the positive. And then I finally multiply out my last values. I need a calculator for that one. And then we clean it all up. So we have x to the fourth plus 6x cubed plus 34x squared plus 150x plus 225. So barring that I didn't make any mistakes here, that should be our polynomial. And that's it. So hopefully going through those, I know a lot of the other questions were just duplicates of the same thing. So hopefully that cleared it up, and hopefully the mistakes were just based on how the questions were asked to you and not that we didn't know the content. We still will be working with the writing of the polynomials, like that last question with the imaginary numbers in class. Okay, so again, hopefully this helps you out.